In this video, we're going to talk about naming alkenes. Let's go over a simple alkene. How would you name this one? As you can see, we have 1, 2, 3 carbons. We want to start counting the carbons from the side that the double bond is closest to. Since we have 3 carbons in total, this is going to be you normally call it propane if it was an alkane, but since it's an alkene, we're going to go propene. If you have an alkene that has more than 3 carbons in its main chain, you're going to have to put a number before it. In this example, we have 1, 2, 3, 4. We want to start counting from this side because that's where the double bond is closest to. When you look at this situation, you can see that the triple bond is, or not the triple bond, the double bond is in between carbons 1 and 2. So you're going to number it, the lower one, which is 1. And then you have 4 carbons, which is associated with butene. So 1-butene is the name of this one. Now, what if the triple bond were to be between these 2 carbons? How would you name this one? You'd still call it butene, however, it's the double bond is between 2 and 3, so it's going to be the lower one, 2-butene, as opposed to 1-butene. If we want to count the carbons in this alkene, if we go from right to left, we're going to get 3 and 4 across the double bond. If we go left to right, we're going to get also 3 and 4 across the double bond. So it doesn't matter which way we count. Either way, we're still going to get 3 and 4. We have 6 carbons in total, which is associated with hexene. And 3 is the lower number across the double bond, so 3-hexene is going to be the name of this compound. How would we name this compound right here? If we start counting at the side of the double bond, we're going to have this order, and we're going to have 7 carbons, which would be associated with heptene. Double bond is across carbons 1 and 2. We're going to go with 1 because it's lower, 1-heptene. We have a methyl substituent on carbon number 3. So on position 3, we have a methyl. So this is going to be 3-methyl, 1-heptene. Let's go over this next example where we have 2 double bonds in the same compound. How do we name this one? So once again, we want to always start by counting the carbons. And we have 6 carbons in this case, which would be associated with hexane. However, since we have 2 double bonds, this is going to be hexadiene. That's going to be the suffix. Hexadiene. Di means 2, and then the ene means the double bond. We also need to indicate the positions at which the 2 double bonds are at. The first double bond on the right is in between carbons 1 and 2, but we're going to go with 1 because it's lower. The other one is in between 3 and 4, we're going to go with 3 because that one's lower. So it would be 1, 3 dash hexadiene. How about this example? How do we name this one? This molecule is actually symmetrical, so it doesn't matter if we count right to left or left to right. We have 5 carbons in total, which would be equivalent to pentane, but we have 2 double bonds, so that's pentadiene, as we talked about. The double bonds are in between are going to be on carbon 1 and 4. So 1, 4 pentadiene, and then we have a 3-chloro, and that's the name of your compound. Let's say we have a ring, and let's say we have this ring with a double bond right here. How do we name this ring? So whenever you have rings, you're going to call it cyclo, and then whatever the parent chain name is. If you count all the carbons in this ring, you can actually see that we have 5 carbons. So that would be pentane. However, we have a double bond, so it's pentene. You don't need to number the double bonds in this one because it's already assumed that the double bond is on carbon 1. So you can just call it cyclopentene. If you put numbers around that, you can just rotate it and then you get the same thing. How do we name this ring structure? If you count the carbons in the main chain, you have to include the double bond. So we're going to go toward the ethyl as opposed to this way, because then we'd get to ethyl quicker, so ethyl would have the lowest number possible. As you can see, we have 6 carbons in total, which would be equivalent to hexene, but since we have a ring, it's cyclohexene. We have an ethyl substituent on position number 3, so this would be 3-ethyl, and we put it on like this, and this should all be one word: 3-ethyl cyclohexene.